Question 29. Separate pieces of aluminium foil and copper foil are heated in air. The copper foil reacts to give a black solid, that is copper 2 oxide. Then aluminium foil does not react. Okay. Which statement explains these observations? Now, already aluminium, by the time you put it in air to react, it has already reacted. Okay. So aluminium actually reacts with the oxygen. What am I writing? Sorry. To give this aluminium oxide. Okay. That aluminium oxide there, if I can balance this, I can put a 2 here. And then we have a 4 and then a 3 here. So this aluminium oxide is a protective layer. That is why we are in position to have these electric cables, okay, overhead electric cables, these ones here. There is that protective layer of aluminium oxide that protects them. This one cannot react with water, so that's why they can be there for ages and ages. Okay. Now, which statement explains these observations? Aluminium has an unreactive layer, but copper does not. That is the aluminium oxide which I've talked about. But let's look at this. Part B, aluminium is below copper in the reactivity series. No, aluminium is actually way above copper in the reactivity series. That is why if you get aluminium and you drop it in an acid, you will see bubbles of the gas. Hydrogen will be given off. But for copper, you can put it in the acid and you wait until the end of age. It will not react because it is way below hydrogen in the electrochemical series. So it cannot derive hydrogen from the acid. Okay, even water. So that is that. And then, so B is off. Copper reacts with moisture in the air. Okay, but aluminium does not. Copper does not react. I've just told you it is below hydrogen in the electrochemical series. Okay, then D, copper reacts with nitrogen in the air, but aluminium, no, that one's very wrong. So our answer here has to be A. Then question 30, which row gives the symbol equation for the formation of carbon monoxide and for the reduction of iron 3 oxide in the blast furnace? Now, in the blast furnace, this is what we are having. First of all, the coal that is put there, now we shall say the carbon reacts with the oxygen because there is hot air, and then you get carbon dioxide. Now, as this carbon dioxide rises, it still finds more coke coming in, and then it reacts with it, then it is reduced to carbon monoxide. Now, this carbon monoxide is the one that reacts with the melted iron 3 oxide, okay, the hematite that is there. And then when it reacts with it, then this one is reduced. Okay, actually iron is below copper. I mean, iron is below carbon in the electrochemical series. That is why it is capable of reducing the iron 2 oxide. Then you can get iron, which comes out as a liquid, and then carbon dioxide, which comes out as a gas. You see? And then maybe another reaction, actually balancing this will be like that. And I think 3 here to make it a 6. So another reaction is actually calcium carbonate, which is added there. It is first thermally decomposed to calcium oxide, then plus carbon dioxide. Okay, and then this calcium oxide that is formed is the one that reacts with the impurity in the hematite, which is silicon 4 oxide, the sand, and then it comes out as calcium silicate, which we call slag. Okay, so that is actually the process. Now let's look at what they're telling us here. Equation for the formation of carbon monoxide, it has to be carbon dioxide reacting with carbon, like I've shown you here. You see this one here? And then the equation for the reduction of iron 3 oxide is this one here. So let's check, where are we having them? I can see this and this, but then here there is this one here and this one here. So don't you think the answer is D? Yes, the answer has to be a D here. Okay, because that is where I'm having the two ticks.